Alright, welcome everyone to the AI Research Roundup. I'm your host Alex, and today we're diving into this article by OpenAI titled Introducing GPT-4.1 in the API. So essentially, OpenAI has launched 3 new API-exclusive models, GPT-4.1, GPT-4.1 Mini, and GPT-4.1 Nano. They're boasting some serious performance boosts over previous versions, especially in coding, instruction following, and, well, long context comprehension. They've also expanded the context window to a whopping 1 million tokens and updated the knowledge cutoff to June 2024. Okay, so this figure charts the model's intelligence against their latency, using the multilingual MMLU as the intelligence benchmark. Interestingly, GPT-4.1 Mini shows higher intelligence than GPT-4.0 Mini, despite presumably lower latency. Likewise, GPT-4.1 outperforms GPT-4.0 on this metric as well. And then we have GPT-4.1 Nano, positioned for low latency applications. So this figure focuses on coding performance, specifically on the SWE bench verified test. It shows GPT-4.1 achieving a remarkable 55% accuracy. Well, that's a substantial jump from GPT-4.0's 33%, and even surpasses GPT-4.5. Interestingly, GPT-4.1 Mini also shows a significant improvement over its predecessor, reaching 24% accuracy compared to GPT-4.0 Mini's 9%. This really highlights the coding advancements in this new model series. Next, this figure illustrates the model's performance on GSM-8K, a grade school math problem dataset. So, we see GPT-4.1 achieving a solid 52% accuracy. Okay, that's a notable improvement over GPT-4.0's 31%. GPT-4.1 Mini also performs well at 35%, exceeding GPT-4.0 Mini's, well, a mere 4%. Even GPT-4.1 Nano manages a respectable 10% on this challenging dataset. Moving on, this figure presents internal OpenAI data on instruction following accuracy, specifically on a hard subset of tasks. So, GPT-4.1 hits 49% accuracy, a good jump from GPT-4.0's 29%. Interestingly, GPT-4.5 scores even higher at 54%. Then, looking at the mini models, GPT-4.1 Mini achieves 45%, considerably better than GPT-4.0 Mini at just 27%. Even GPT-4.1 Nano shows a decent 32% accuracy here. Okay, so this figure shows performance on the multi-challenge benchmark, which tests how well these models handle multi-turn conversations. We see GPT-4.1 scoring 38%, a noticeable improvement over GPT-4.0's 28%. Interestingly, GPT-4.1 Mini also performs well at 36%, even outperforming some of the larger models like OpenAI o3 Mini. And GPT-4.1 Nano achieves 15%, significantly better than GPT-4.0 Mini's 20%. So, this highlights improvements in conversational abilities across the board. Okay, so this figure displays the results from the IF-eval benchmark. This tests how well the models follow instructions. Well, GPT-4.1 achieves 87% accuracy, outperforming GPT-4.0 and even GPT-4.5. Interestingly, GPT-4.1 Mini also performs very well at 84%, exceeding GPT-4.0 Mini's 78%. So this again reinforces the improvement in instruction following that we've seen across these new models. Alright, this figure details performance on the GraphWalks benchmark, testing. Essentially, breadth-first search within a large graph. So, GPT-4.1 and GPT-4.1 Mini both hit 62% accuracy. Interestingly, GPT-4.5 actually performs best here at 72%, while GPT-4.1 Nano achieves 25%. This benchmark seems to focus on long context reasoning, a key area of improvement mentioned earlier. So this figure looks at MMMU accuracy, which tests the model's ability to answer questions based on charts, diagrams, and maps. GPT-4.1 achieves 75%, outperforming GPT-4.0 at 69%, and matching GPT 4.5. Okay, interestingly, GPT 4.1 mini also scores well at 73%, significantly better than GPT 4.0 mini's 56%, and GPT 4.1 nano achieves 55%, which is also pretty respectable. So this figure focuses on long context understanding, specifically using the video MME benchmark. It involves answering questions about 30 to 60-minute videos without subtitles. We see GPT 4.1 achieving a 72% accuracy, which is a nice improvement over GPT 4.0's 65%. This aligns with the overall trend of improved long context comprehension we've been seeing. Finally, this table shows the pricing for these new models. So the blended pricing for GPT 4.1 is $1.84 per million tokens. GPT 4.1 mini is considerably cheaper at 42 cents. And, well, GPT 4.1 nano is the most affordable at just 12 cents per million tokens. This makes them quite competitive, especially considering the performance gains we've discussed. This table then presents performance on several additional benchmarks. Alright, so we see scores for AMI24, GPQA Diamond, MMLU, and Multilingual MMLU. GPT 4.1 performs very well across the board, often exceeding 90% accuracy. Okay, the mini and nano models also show strong performance, especially GPT 4.1 mini on MMLU, hitting 87.5%. This further emphasizes the broad improvements in these new models, not just in coding and long context, but also general knowledge and reasoning tasks. Next, this table provides further details on coding benchmarks, specifically SWE Bench, SWE Lancer, and Ader's Polyglot. GPT 4.1 achieves a strong 54.6% on SWE Bench, considerably higher than GPT 4.0 and GPT 4.5. Okay. The table also shows impressive cost savings with SWE Lancer, where GPT 4.1 mini achieves comparable performance at a much lower cost. And, well, we also see good performance on the Ader's Polyglot benchmark, further demonstrating the improved coding capabilities of these models. Building on these results, this table shows performance on the OpenAI MRCR benchmark, which focuses on multi-round CO reference resolution. So, GPT 4.1 achieves 57.2% accuracy on the Needle 128K version. GPT 4.1 mini scores 47.2%, and Nano gets 36.6%. This is compared to GPT 4.0 at 31.9% and GPT 4.5 at 38.5%. Well, the next row shows similar results on a different version of the MRCR benchmark, highlighting again the significant improvements in CO reference resolution with these new models. Moving on, this table shows performance on various instruction following benchmarks. So, for internal API instruction following, GPT 4.1 achieves nearly 50% accuracy, while the mini and nano versions reach 45% and 32%, respectively. Okay. The table also shows results for multi-challenge and a variation using a different grader model. Additionally, we see scores for Kali, IF-Eval, and Multi-IF, showing generally strong performance across the board for the 4.1 models, especially compared to GPT 4.0 and 4.5. Okay, this table presents performance on the GraphWalks benchmark, focusing on, well, long context reasoning. It seems to break down the results based on different dataset sizes, using Needle 1M and then variations of BFS and parents, above and below 128K. We see GPT 4.1 achieving over 60% on the first two rows and comparable results in the third. The smaller subsets seem to present more of a challenge though, as seen in the last row with lower percentages. So this gives us a more nuanced view of long context abilities beyond just the overall video MME scores we saw earlier. Okay. So this table details performance on MMLU, MathVista, and, well, Charsoir and Charsoir-D. GPT 4.1 consistently performs very well, often exceeding or matching previous models like GPT 4.0 and 4.5. The mini and nano versions also show solid results, especially GPT 4.1 mini, which sometimes even surpasses GPT-4.0. This reinforces the idea that these new models offer improvements not only in specialized areas, but also in these more general knowledge domains. Alright, this table shows performance on complex Funk Bench and Tau Bench airline to the power of 4. So GPT-4.1 achieves 65.5% on complex Funk Bench, while the mini and nano versions get 49.3% and 5.7% respectively. Okay, for Tau Bench airline to the power of 4, we see scores of 49.4%, 36%, and 14% for GPT-4.1, Mini, and Nano. These are compared against GPT-4.0, its Mini version, and, well, OpenAI O1 and O3 Mini, as well as GPT-4.5. So it looks like GPT-4.1 is performing well here too. Next, this table shows Tau Bench retail benchmark results. So, GPT-4.1 achieves scores ranging from about 22% to almost 71% across different aspects of the benchmark. Interestingly, the numbers in parentheses show even better performance when GPT-4.1 is used as, well, the user model due to its improved instruction following. This suggests that the true capabilities of the model might be even higher than the initial results indicate. So, wrapping up this article by OpenAI on GPT-4.1, these new models offer significant improvements in coding, instruction following, and long context understanding, outperforming previous versions like GPT-4.0 and 4.5. Well, they've also introduced a nano version for faster, more cost-effective performance. Okay, thanks for tuning in to the AI Research Roundup. This is Alex, signing off.